Welcome to PDMA Corporation, home of the MCE Max. I'd like to thank you for joining us as we continue along in our presentation series. Once again, we have the Vice President of Product Development, Mr. Noah Bethel.
Hello from sunny Tampa, Florida.
And I am Todd Gunderson, the Vice President of Sales and Marketing. And Noah, our customers continue to send us great information that we can present to our peers out there.
And I like the words found early. That's the whole idea of condition-based maintenance. Find it early.
Yeah, so this is a high resistance connection case study sent to us by our good friends in the pulp and paper industry. So this is the nameplate. Nothing too dramatic about this nameplate. Probably millions of these motors out in industry today.
Yeah, 4-pole, 365T, very common.
Very common motor. And this was during routine testing, we found this 3.63% resistive imbalance.
You gotta like those pre-established alarm set points. Again, we like to check them every year, but that 3.6 is an unacceptable resistive imbalance. And what we're looking at is just the balance between the three phases, sending a DC signal through those from the starter to the motor and seeing if there should be a balance between those three phases. Right.
So some of the next testing we wanted to see, is there any insulation concerns? So they did a polarization index test, and we see it's a relatively, it's low. It's in caution for the polarization index, and only 300 gigohm or 300 megohm, excuse me. So we're not sure exactly. This is our first test on that. So let's do some more testing.
Absolutely.
But we did an online test of this motor. We don't really see anything in the current. Why is that? We had a high resistance connection, but nothing is translated into the current yet.
This is a common misconception that current and resistance are directly linked. And keep in mind, resistance is an element, almost like a DC circuit element, and even an AC circuit, it's the power drop locally. Thermography and phase resistance are two very early indicators of a power circuit anomaly, and they see things very early in that PF curve. Current, however, is affected by impedance, which is an AC influence. And if you allow a power circuit anomaly to get bad enough to affect the current, you've waited until a late in the PF curve. So it's a lagging indicator. So we always say, hey, power, a resistive imbalance is an early indicator. If you fix it now, you've removed the conditions conducive to a big time failure, and don't wait till it affects the current.
So maybe there's some excess heat at the point of high resistance?
Absolutely. You'll see that from phase resistance. You'll see it on thermography. But as you get beyond that...
But you won't see it through the whole system.
Correct. Yet. It has no immediate effect on the motor, but it is a reliability issue.
Okay. That's a great explanation. So what we found was this is a motor located on a roof. And it was basically, there was some water leaking down about 15-20 feet to a C connection where it was pooling in that C connection box, and thus causing the increase in resistive imbalance, and certainly maybe the lower resistance to ground.
Water always finds a way, doesn't it?
Yeah. Now this motor had to run to failure. It's a $4,500 to replace it, but the last 6 years they've spent on average $2,200 to refurbish, and that meant new bearings. And we're going to pay attention to that because there's some more data we want to share on this. And the replacement motor, this is always tricky when you hear this. The cost doesn't seem that expensive, but boy, when you start talking about the man hours and the time involved, and then a crane.
Oh my goodness. Yeah, it almost, you start to question the design engineering. Is there any way we could have made this a little easier, thinking ahead about the repair practice? And for new establishments, that's a key element.
And we always say, what do we call us before you call the crane? That's a common phrase that we use. So we're glad that they took our information for our data, and they didn't have to call the crane on this one. And here's a picture of the damage that was over time, I'm sure, created that rusting in there. So they were able to drill a couple holes in there possibly to let that water drain out, and then maybe patch up some of the ceiling on the top of that roof so that it didn't leak down those cables. And then after they repaired that, this is the information that you collect. It's a good opportunity to go in and let's see that the fix actually was corrected.
Absolutely, because too often we see infant mortality. You go in and you modify something, and that's when it ends up being in failure mode. So sometimes a corrective action isn't always a corrective action. It ends up causing more problems. This follow-up test, it went from a 3% to a 0.2% motor only, and even with the new leads, it's 0.8%. It's well under 1% resistive imbalance, which is kind of a milestone. You don't want to be over 1%.
Right. So we've fixed that. We feel comfortable on that. Now there was some more data that I mentioned earlier in this case study, but before we get into that, we did this polarization index test showing a big jump, almost 10 times what the resistance to ground was versus the old polarization index test. And this is the data that we said that they collected a tremendous amount of information, which we always encourage. We want people to get as much data as possible. So if you can do an online test, an offline test, and all the tests involved in each of those sections, what is this telling us here? This is an inrush startup test we're looking at.
Yeah, so we'll apply our inrush startup test sometimes while the motor's running as a process analysis tool. What it does is it gives indications of torsional load changes that might occur that are often something other than electrical. A lot of times if you see this type of modulation, if you look at that, it's about 10 cycles in a second, and a lot of times we'll look at that as a possible rotor anomaly, but at this frequency, it's a little bit high for a rotor anomaly. So you start to say it's probably some type of machine train, whether it be bearing, compressor, the load changes, something like that.
So we'll look at the rotor, right? And we see that there is a pole pass there. It's not at the observed level, but we're going to pay attention to that over time. It's good to know this, right? It's good to have a trend on this asset. Yes. So we know we're not in any type of concern yet with our rotor because our pole pass sideband hasn't reached an observed line. But we go out to the fifth harmonic and we see this here. What is this telling us?
So the X's, which is going to draw a lot of people's attention, are the swirl effect. And we like to track that in the event of a possible rotor defect. Now, without the correlating pole pass from the previous example, we're probably going to just continue to observe that rotor health. The bigger concern is the fact that that fifth harmonic there at 300 hertz, instead of one peak, which is what we've grown to expect, is actually two. We call it a split fifth harmonic peak. Very commonly produced by a result of an axial movement in the shaft. This is usually caused by an offset in the magnetic center of the motor itself. Now, how does that happen? You put the motor back where the other one was, and you put the coupling together, and you bolt it down, and if it pulls the motor shaft out of magnetic center, constantly that motor's trying to hunt back and forth to get back to magnetic center, thus creating that modulating, graph that you showed earlier.
Right, and that's that sideways movement as it's trying to find, you're just putting undue stress on that bearing, which may go back to where they spent on average $2,200 for bearing replacement and things of that nature. So kudos to the team there for taking this amount of data, but we would highly encourage them to go out and do a visual inspection of this asset. Once they've already found the high resistance, now they need to look at some other things on this motor.
Absolutely.
Well, that brings us to the end of this great case study, and as always, we thank you for your time. If you have any information that you would like to share with us, some case studies, we'd be more than happy to entertain it, put it together for you, and present it to your peers out in the audience. Until then, you guys have a safe weekend, a safe day out there, and we look forward to talking to you again real soon. Thank you.